topic ano. So ito ay part pa rin ng sa crystal. Okay, so before tayo diyan pala, ayun ano, tapos na tayo sa unit cells. So again, 4 yung ating diniscuss by concept. Ano, alam natin yung number of atoms ng each, ano, yung 4 na yun. So si SC, si FCC, si BCC, tsaka si HCP. So by concept, ano, alam din natin yung kanilang, um, anong tawag dun? Ay, ano ba yan? I forgot. Si, um, coordination number. Ayan. Ating coordination number ano. So, si coordination number naman, hindi naman siya nagagamit sa calculations, ano, sa ating density calculations. Pero dapat ano niya rin, alam niya pa rin siya ano for each type ng ating unit cell. So iba-iba 'yon and again hindi naman siya nagbabago. Ano, tapos for the three, yung ating SC, FCC and BCC, alam din natin at na-discuss na din natin and aware na tayo ano dun sa iba't iba nilang um, formula to determine yung ating edge length ano and in uh, eventually makukuha din natin yung ating volume ng cell using that formula ng um, edge length ano ayun. Tapos again yung HCP natin hindi siya isasama sa calculations ano. So sa problem solving hindi siya kasama. Ang pagfo-focusan niyo lang sa HCP is yung kanyang concepts, ano, yung kanyang number of atoms, yung kanyang structure, ano kung anong itsura niya, ayan. Uh, and then, um, at saka yung definition niya by itself, kung ilang atoms at saka kung ano-anong atoms yung nasa structure niya. Ayan. Tapos, tapos na din tayo sa pag-compute ng density ng crystals, ano, based on the um, type of unit cells, ano. Um, And then, yun nga, few reminders, yung nabanggit ko kanina, ano, puwede naman na gamitin yung formula ng density na mass over volume, but be careful doon sa substitute ng values, ano, lalong-lalo na dun sa mass na part. So kung kailangan ang mass ay, in terms of unit cell, ano, hindi sa atomic weight. Okay, yung mismong mass ng crystal or mismong mass nung, um, element or crystal itself na yun, okey? Yun lang, tapos unit, maging maingat rin dun sa pag pagsulat ng mga formulas kapag nagde-derive ng formula ano, so para kasi kapag ang sinundan niyo, nag-derive kayo ng formula and then nagkamali kayo ng sulat katulad nung nangyari kanina, ano, so magiging mali din yung sagot ninyo, ano. So, ano lang, maging maingat doon sa part na yun. So, madali lang naman yung mga, itong computation na yan. So, diyan lang naman yun iikot, ano. So, hindi naman na yun masyadong complicated, ah, yung mga problem na may-encounter ninyo regarding dito, ano. So, hangga't alam ninyo nakinig kayo sa discussion natin dito sa ating problem solving, so kaya-kaya niyong sagutan 'yun, yung mga ano, problem sa quiz at saka dun sa final exam natin, ayan. So, again nga pala, speaking of final exam, yung ating final exam is unlike dun sa midterms natin, na majority is computation ano, so dito sa ating final, coverage, minimal na lang yung ating computation ano. So, ang first computation natin is yun, yung density calculations sa crystal ano, per type ng unit cell. And then may isa pa na next, so sa mga susunod na linggo yun. But I think yun lang, ta's after nun ano na, I mean, ah majority nung ating ano, nung ating topic dito sa finals is, ano na, concepts, ayan. So ang expect na majority ng tanong sa exam natin would be ano na, concepts na, ano. Meron pa ring computation but hindi na gano'n karami yung, ah, points ano, number of points niya. Okey. So tapos na tayo sa unit cells, ano, so doon naman tayo sa tinatawag nating X-ray diffractions by crystals. So, itong X-ray diffraction nabanggit ko 'to sa inyo ko last week ano, dun sa briefly, I mean, briefly lang, dun lang sa in terms of yung pagdi-differentiate ng crystalline solid and amorphous solid. So yung isa sa mga nabanggit kong difference ng crystalline solid to amorphous solid is yung, pattern na napo-produce ng, crystalline solid kapag exposed sa X-rays. So yung, process na iyon ay tinatawag na X-ray diffraction, by crystal. So, X-ray diffraction refers to scattering of X-rays by the units of a crystalline solid. So the patterns produced by scattering or diffraction are used to deduce the particle arrangement in the solid lattice. So yung X-ray na yan, so yung mismong process ng X-ray diffraction, so mas ma-e-explain siya ng maayos later. May video akong papanood sa inyo. So yung concept lang naman nun, but yung kailangan yung ma malaman, ayan. So X-rays are one form of electromagnetic radiation. So therefore, we would expect that waves exhibit such behavior under relevant conditions. So si Max von Laue, a German physicist, recommended that since the wavelength of X-rays is comparable in magnitude to the distances between lattice points in a crystal, then the lattice should be able to diffract X-rays. So from itong X-rays na yan, yung process na X-ray diffraction, using uh, X-rays, yung waves na napoproduce, in patterns. So, nako-compute yung, natin, iba't ibang, um, units ni crystal. For example, yung edge length, yung density, pwede rin. So, interferences in the waves associated with X-rays produced an X-ray diffraction pattern. So, yung X-ray diffraction pattern, ito yan, yung dalawang um, figure. So, ito, A and C, B. So, magkaiba yan. So, ito sila. So, si figure A, is tinatawag nating constructive interference. So, si constructive interference, makikita natin, si wave 1 and si wave 2 is same. Identical. Yung kanilang direction, yung wave pattern, ayan. So, kapag pinagsama yan, sa or sum of wave 1 and 2, so ganito yung magiging itsura niya. Same pa rin yung um, itsura. It's just that parang extended. And then ito namang figure B, tinatawag nating destructive interference. Ayan. Same din, two waves, same wavelength, at saka amplitude, but yun, magkaiba ng pattern na produce. Ayan. So makikita natin si wave 1, from up, pababa. Tapos si wave 2 naman, nagsimula siya sa baba, pataas. So kapag pinagsama, ito yung magiging itsura niya. So parang na-deduct yung yung dalawang waves. Okay? So yan, yung diffraction pattern, dalawa, constructive and destructive. Okay, so ganito naman ginagawa yung X-ray diffraction by crystal. So a beam of X-rays is directed at a mounted crystal. Atoms in the crystal absorb some of the incoming radiation and then re-emit it. So the process is called the scattering of X-rays. Ayan, so merong X-ray tube, tas merong crystals. Ayan. So, yung atom sa crystal, sorry, na-absorb yung incoming radiation tapos nire-re-emit siya. So, kaya siya nagpo-produce ng pattern or scattering ng X-rays. So the X-ray diffraction technique gives the most accurate method for determining bond lengths and bond angles in molecules in the solid state. So chemists can construct an electron density contour map from the diffraction patterns because X-rays are scattered by electrons, but it is with the use of a complex mathematical procedure. So from using yung ating X-ray diffraction, so siya yung most accurate na ginagamit ng chemist for determining yung bond lengths ng crystals, tsaka yung bond angle. So from that, yung using yung patterns na napoproduce ng X-ray diffraction, so nakakapag-map sila ng tinatawag na electron density na contour map. Ayan. So this electron density contour map basically tells us that the relative electron densities at various locations in a molecule. So the densities reach a maximum near the center of each atom, and in this manner, we can determine the positions of the nuclei and thus the molecular geometric parameters. Ayan. So again, yan nabanggit ko sa inyo kanina, so itong X-ray diffractions, bukod doon sa um, yung bond lengths and bond angles na kanyang na determine so sa further study by using yung electron density contour map, malalaman yung mga relative na electron densities at saka location and then eventually makakapag determine din siya ng yung position ng nuclei at saka yung patterns, geometric patterns. Ayan. So, panoorin natin yung video. Wait lang, hindi ko siya share ako screen. So, it's just a 4-minute video naman. Okay, confirm ako kapag naririnig. Paki-react na lang siguro ng anything like or heart.
What is X-ray diffraction, and what is it used for? In an X-ray diffraction experiment, a sample is placed into the center of an instrument.
Okay, i-play ko na
What is X-ray diffraction, and what is it used for? In an X-ray diffraction experiment, a sample is placed into the center of an instrument and illuminated with a beam of X-rays. The X-ray tube and detector move in a synchronized motion. The signal coming from the sample is recorded and graphed, where peaks are observed related to the atomic structure of the sample. Most materials are made up of many small crystals, like sand on a beach. Each of these crystals is composed of a regular arrangement of atoms, and each atom is composed of a nucleus surrounded by a cloud of electrons. It's at this scale that the story of X-ray diffraction begins. X-rays are high-energy light with a repeating period called the wavelength. Since the wavelength of an X-ray is similar to the distance between atoms in a crystal, a special interference effect called diffraction can be used to measure the distance between the atoms. Interference occurs when X-rays interact with each other. If the waves are in alignment, the signal is amplified. This is called constructive interference. If the waves are out of alignment, the signal is destroyed. This is called destructive interference. When an X-ray encounters an atom, its energy is absorbed by the electrons. Electrons occupy special energy states around an atom. Since this is not enough energy for the electron to be released, the energy must be re-emitted in the form of a new X-ray with the same energy as the original. This process is called elastic scattering. In a crystal, the repeating arrangement of atoms form distinct planes separated by well-defined distances. When the atomic planes are exposed to an X-ray beam, X-rays are scattered by the regularly spaced atoms. Strong amplification of the emitted signal occurs at very specific angles, where the scattered waves constructively interfere. This effect is called diffraction. The angle between the incident and the scattered beam is called 2 theta. In order for constructive interference to occur, the scattered waves must be in alignment, meaning that the second wave must travel a whole number of wavelengths. In this case, 1/2 of a wavelength is traveled on the incident side, and 1/2 on the scattered side, yielding 1 additional wavelength. In the case of the next X-ray, 1 wavelength is traveled on both the incident and the scattered side, resulting in 2 wavelengths. This reinforcement occurs throughout the crystal. The exact angle at which diffraction occurs can be determined from the red triangle. The angle at the top is theta, half the angle between the incident and scattered beams. The long side is the distance between the atomic planes, and the short side we know is 1/2 of a wavelength. The relationship between the diffraction angle and the spacing between the atoms can be determined by applying the sine function. Rearranging this equation yields an equation commonly known as Bragg's law, named after Sir William Henry and William Lawrence Bragg, a father-son team who won the Nobel Prize in 1915 for their work analyzing crystal structures with X-ray diffraction. This technique of X-ray diffraction is used today for a wide variety of materials, ranging from single crystal epitaxial thin films to polycrystalline mixtures of powders and even randomly oriented amorphous materials. X-ray diffraction helps scientists to develop new pharmaceuticals, classify rock formations based on their mineral components, and understand how the arrangement of atoms affects the behavior of energy storage materials. As scientists push their ability to engineer materials on the atomic level, X-ray diffraction becomes an increasingly important tool in their toolbox. Advances in equipment design have made X-ray diffraction easier to use and more powerful than ever.
Ayan. Okay, so hopefully naintindihan naman yung concept nung X-ray diffraction process. So, yun lang naman yung inyo maintindihan doon. So, maganda yung video na yun since hanggang sa application sa industry, sa iba't ibang industry yung nabanggit doon. So, isa doon yung pharmaceutical, isa doon yung sa pag-identify ng chemical components ng rocks, ng mga rock formations, So, yung mga identification ng chemical component within a rock or rock formation, yun yung nakakatulong sa pag-identify ng what type of rock is that, or what type of crystal is that, things like that. Yan. Okay, balik tayo dun sa natin, slideshow. Okay. So, tapos na tayo sa X-ray diffraction, by crystals, in concept. So, ang next naman natin is identifying the types of crystals. So again, ito ay briefly na ko din, na discuss, dun sa part na pag-differentiate sa crystalline solid and amorphous solids. So, yung yung type ng anong tawag dito, type ng crystals sa crystalline solid is nakadepende dun sa forces na nagho-hold sa each atom together, atom or molecule together. Ayan. So, basically yun din yung natin, basihan dito ng type of crystals. So, in determining the structures and properties of crystals, such as melting point, density, and hardness, it is important to consider the kind of forces that hold the particles together. So, basically, yung kind ng force na nag-hold dun sa particle or atom or molecules together is yun yung nagde-determine ng magiging hardness, melting point, density, and other properties at characteristics ng isang crystal. So, meron tayong 4 classifications of any crystals. So, meron tayong tinatawag na ionic crystal, covalent crystal, molecular crystal, at metallic crystals. So, again, ito ay classification based on the kind of force na nag-hold ng atom or ng particles or molecules together. So, sa ionic crystals, there are 2 important characteristics of ionic crystals. So, first is they are composed of charged species. And then, second is anions and cations are generally quite different in size. So, this is in terms of electrons. Yan. So, the radii of ions must be known because it is helpful in understanding the structure and stability of these compounds. So, it is hard to measure the radius of an individual ion, but sometimes it is possible to come up with an estimation. So, Ayan. So, etong, determine ano ng radius or radii ng isang, ions ay, helpful ano kumbaga nakakatulong sa determine or pag-understand, pag-analyze ng, um, ano nila, magiging structure um, nung compound ano or nung crystal which in turn kapag yung structure ng compound ano, may it be uniform, ah, not uniform or arrange ano or, kumbaga may distinct na pattern, yun yung, magde-determine din kung stable or non-stable yung, isang crystal. Okay, so eto for example, the sodium chloride crystal which has a face-centered cubic lattice shows that the edge length of the unit cell of, sodium, chloride is twice the sum of the ionic radii of, Na plus and Cl minus. Ayan, so getting the values daw of ionic radius, um, given this, yung calculated lengths ng edge is ang nakuha nila is, 552, picometers. Tapos, basing on the ano yun, yung 552 picometers na yan basing on the, um, ano lang, edge length na estimated edge length, using yung, ano natin, 2 ions which is the, sodium at saka yung chlorine But the edge length shown was determined by X-ray diffraction which has a value of 564 picometers. So, ibig sabihin merong difference sa values ng dalawa, although maliit lang naman. So, the difference between these two values tells us that, the radius of an ion actually varies slightly from one compound to another. And so again, yung ating X-ray diffraction, isa yung edge length sa, values na puwedeng makuha from that, process ayan. So meron tayong, crystal structures, ito ABC. Crystal structures of, cesium chloride, letter B is for zinc sulfide, and then for, C is calcium difluoride. Ayan. So cesium chloride ay ang kanyang, structure, cubic crystal structure is simple cubic lattice, because, cesium is considerably larger than, um, sodium. So makikita naman natin na corner atoms lang yung ko-connect And then for, zinc sulfide naman, zinc blende structure which is, based on the FCC or face-centered, cubic lattice. And then, itong letter C which is calcium difluoride, ah has a fluorite structure na based din sa FCC. So yan ay nakadepende dun sa type ng, mga element na kasama nila doon sa structure, doon sa crystal na iyon So, gaya na nabanggit natin dito kanina, yung difference daw ng values tells us that the radius of an ion actually varies slightly from one compound to another. Ayan. So yun yung ating, ah structures, example ng ionic crystal. So, most ionic crystals have high melting points, which is an indication of the strong cohesive forces holding the ions together. So, this is because, kaya siya may high melting points is because yung sa crystalline solids, yung ionic crystals is very distinct. Tapos yung forces na nag-hold sa kanila together is via ionic bond. So the measure of a stability of ionic crystal is the lattice energy. So the higher the lattice energy, the more stable the compound. So since the ions are fixed in position, therefore the solids do not conduct electricity. So yung um, ionic crystals natin in solid form, hindi siya nagko-conduct ng electricity. So ibig sabihin siya ay full conductor. But pwede siyang mag-conduct ng electricity kapag lang siya, in molten state or kapag melted. So ibig sabihin kapag yung temperature ay uh, na-reach yung high melting points ng isang ionic crystal. So ibig sabihin at high temperature, lagpas dun sa melting point ng ionic crystal, is yun nga, yung temperature is higher than the melting point ng ionic crystal, specific ionic crystal na iyon. So, ibig sabihin, nandun siya sa molten state, or melted siya, pwede siyang mag-conduct ng electricity in a liquid form. So, pwede din mag-conduct ng electricity yung, kapag yung ionic crystal natin ay dissolved in water. So, 'to lang. Kapag siya ay molten state at kapag siya ay dissolved in water, dun lang siya nakakapag-conduct ng electricity. But in solid form, hindi siya nagko-conduct ng electricity. Okay? Ayan. So, next type naman ng crystal would be covalent. Covalent crystal. So, ito naman ay, ang forces na nagho-hold dito ay via covalent bonds. So, covalent crystals exist when atoms are held together in an extensive three-dimensional network altogether by covalent bonds. Okay, example are the two allotropes of carbon, which is diamond and graphite. So, meron tayong two examples na covalent crystals, diamond and graphite. So, si diamond ay merong sp3 hybridization. Ano? So, siya ay bonded to four other atoms. So, sp3 hybridization refers to the mixing character of one 2s orbital and 3p orbitals to create four hybrid orbitals with similar characteristics. So, in order for an atom to be sp3 hybridized, it must have an s orbital and 3p orbitals. So, itong sp3 hybridization na yan yung responsible sa pagkakaroon ng similar characteristics ng or similar structures ng atoms or molecules sa uh, diamond. Okay? Thus, the unusual hardness and very high melting point ng diamond, which is 3,550 degrees Celsius, ang melting point ni diamond. So, ang taas niya, are attributed with the strong covalent bonds that exist in three dimensions. Okay, so for graphite naman, carbon atoms are arranged in six-membered rings. So, si diamond ay bonded to four atoms. Ayan. So the atoms are all sp2 hybridized and each atom is covalently bonded to three other atoms. Ayan. So yun yung difference ni diamond at saka ni graphite. So si diamond ay si sp3 hybridized while si graphite is sp2. Ayan. Tapos, since covalent crystal sila pareho, um, very high melting point pareho, yung graphite tsaka si diamond. Although mas mataas lang yung melting point ni diamond. Yan. So ito naman ay figure na nagpapakita ng structure, different sa structures ni diamond at saka ng structure ng graphite. So the structure of diamond sa A, each carbon is tetrahedrally bonded to four other carbon atoms. While itong structure ng graphite naman is into 6. The distance between successive layers is measured as 335 picometers. Ayan. So, yan ay, again, na nakukuha, na-measure yung distance na yun using X-ray diffraction. Okay, ayan. So, graphite naman is considered as good conductor of electricity. So, as well as si diamond, ang diamond ay good conductor of electricity in directions along the planes of carbon atoms. This is because electrons are free to move around in this extensively delocalized molecular orbital. So yung hardness is caused by covalent bond that exists in its layers, which are held together by weak van der Waals forces. So layers of graphite can slide one another. That's why it is slippery to the touch and is effective as lubricants. So, ginagamit ang graphite as pencils and ribbons made for computer printers and typewriters. So, as you can see, yun ay medyo slippery, yung ating graphite. So, another example ng isang covalent crystal pa is tinatawag nating quartz. So, similar arrangement, yung silicon atom in quartz has a similar arrangement to that of carbon in diamond. But in quartz, there is a presence of oxygen atom between each pair of silicon atom. And then, si quartz is similar to diamond in many aspects because of its hardness and high melting point of 1,610 degrees Celsius. So, although marami silang similarities, but malaki pa rin yung difference ng melting point ni diamond ng diamond kay quartz. So si diamond is 3,550 degrees Celsius while si quartz ay meron lang na 1,610 degrees Celsius na melting point. Although high na rin yun, and ano na rin siya, hard na rin na ma re-regard ang quartz, but malaki pa rin yung difference ng when it comes sa hardness and high melting point ni diamond. Okay, so yun yung covalent crystals. So next naman is the molecular crystals. So sa molecular crystals, ito yung pan-third natin. So yung una natin is ionic, then sinundan ni covalent, tapos ito yung third, molecular crystals. So the lattice points in a molecular crystal are occupied by molecules which has a van der Waals forces and or hydrogen bonding. So yan ay maalin. So yung molecular crystals natin ay either bonded by van der Waals forces or hydrogen bonding. So for example, yung sulfur dioxide in solid form is example of an predominantly attracting force. Example ng molecular crystals in which the predominant attractive force is dipole-dipole interaction. The intermolecular hydrogen bonding is mainly responsible for maintaining the three-dimensional lattice of ice. Ayan. Okay. Tapos, the molecules in the molecular crystals, except for ice, are packed together as closely as their size and shape allow. Okay. So, since van der Waals and hydrogen bonding are generally quite weak as compared with yung ionic and covalent bonds natin, so yung molecular crystals are more easily broken apart than ionic and covalent crystals. So, ibig sabihin, si molecular crystals, yung mga crystals na holded together, ng van der Waals forces at saka ng hydrogen bonding ay weaker, kaysa sa mga ionic and covalent crystals. So, additionally, most molecular crystals melt at temperature below 100 degrees Celsius. So, in terms of hardness, weaker si molecular crystals compared kay ionic and covalent. And as well as, mababa lang din yung kanilang melting temperature, which is, they melt at temperature below 100 degrees Celsius. Okay. And then last type ng crystal is the metallic crystal. So metallic crystal has the simplest structure because every lattice points in the crystals are occupied by an atom of the same metal. Yan. So metallic crystals are usually body-centered cubic, face-centered cubic, or hexagonal close packed. Therefore, metallic elements are usually very dense. Ayan. So, ang ano lang dito sa metallic crystal is, siya yung may pinaka-simpleng structure and yung kanyang mga lattice points ay occupied by atom of the same metal. So, walang other metals na involved. So, the bonding electrons in a metal are delocalized over the entire crystals, which is actually different from one type of crystals. So, the metal atoms in a crystal can be imagined as an array of positive ions immersed in a sea of delocalized valence electrons, and these delocalized electrons makes metals a good conductor of heat and electricity. Ayan. And also, metal strength is caused by the great cohesive forces resulting from delocalization. Ayan. So, yung hardness and also yung if sila ay good or poor conductor of electricity ay depende or na-define nung bonding of electrons in a metal. Yan. So yan, ito simpler at saka summarize na difference ng ating apat na types of crystals. So makikita dyan yung types of crystals, yung forces na holding the units together, yung kanilang general properties, so that includes yung kanilang hardness, yung melting point nila, at saka kung sila ay poor or good conductor of heat and electricity. So yung tatlong yun. So, andyan din yung examples. So si ionic, makikita natin dito, si ionic and si covalent, sila yung kumbaga mas madaling mas ito, maraming similarities compared dun sa others. So pareho silang hard, but si ionic brittle siya. So ibig sabihin hard siya but madali siyang masira. Yung kanyang breaking point ay mababa lang. Madali siyang mag-break. And then, ibig sabihin hindi din siya elastic, 'di ba? Pag brittle. High melting point, both high melting point, but si covalent ay mas mataas ang melting point kaysa dun sa mga ionic crystals. Pareho silang full conductor of heat and electricity. So si ionic is yun nga bananggit ko kanina na in liquid form or in molten state at saka kapag dissolved in water lang siya nagko-conduct ng electricity. But in solid form, hindi siya nagko-conduct ng electricity. Tapos dun sa covalent crystals naman, si diamond at saka si graphite na binigay as example kanina is both good thermal conductor. Si diamond is good thermal conductor, pati si graphite, but si graphite is also a good conductor of heat. So itong mga covalent bond ay covalent crystals na like full conductor of heat and electricity ay dun yung majority of the type, other types. Ayan. And then, molecular naman, at saka metallic. So pareho silang soft. Si metallic lang is soft to hard. So basically, we can conclude na in terms of hardness, ang pinaka-soft, pinakamababa yung hardness is yung mga molecular crystals. And then in terms of melting point naman, same, molecular din yung pinakamababa na melting point. So ibig sabihin, sila yung type of crystals na madaling matunaw in higher temperatures. So sinundan ni metallic. Tapos, ionic and then covalent, or other way around. So depende yun. And then, si molecular and si metallic, in terms of conductor of heat and electricity, is si metallic yung good conductor of heat and electricity, tapos si molecular is poor din. Ayan. So, tapos na tayo sa types of crystals. So, in general din, tapos na tayo sa crystalline solids. Since meron tayong two types ng solids, two kinds. So, the crystalline solid and the amorphous solid. So, tapos na tayo all about the crystalline solid. So, dito naman tayo sa amorphous solids. So, ang pinaka-difference ni amorphous solid kay crystalline solid is yung arrangement ng atoms. Yung structure ng atoms or molecules. Ayan. So we all know that crystalline form of solids are most stable, but it is solidify rapidly, then its atoms or molecules do not have time to align themselves and become locked in positions other than those of regular crystals. This resulting solid is said to be amorphous. Okay, so ito naman yung process or a reason ng pagka-form, kung paano na-form ang isang amorphous solid. So, gaya na nabanggit dyan, kapag yung crystal, is nag-solidify ng mas mabilis other than regular crystals. So, yung atoms niya or molecules niya is don't have enough time para i-construct or i-align yung kanilang sarili into distinct patterns, or more distinct pattern, more uniform patterns. Ayan, na repetitive. To align para makapag-produce ng yung crystals na stable, na merong long range of long range of uniform, or repetitive na structure of atoms. Ayan. Ayun, kaya nabubuo yung amorphous solid. Kasi kapag yung crystal or yung crystal natin is nagso-solidify ng rapid. So, dahil nawawala ng time si atoms or si molecules na mag-form ng distinctive pattern. So, ang nangyayari, hindi sila nakakapag-produce ng desired na structure, which is uniform at distinct. So, ayun, since rapid niya. So, yung rapid na tinutukoy ko is not just hours, days, So, it may take lalo na kapag mga crystals na sa mga yung mga nakikita natin as rocks, yan, as crystals. So it takes years. So ibig sabihin, yung rapidly na yan, so not necessarily rapidly, but rapidly compared to dun sa mga regular crystals na nabubuo. So ibig sabihin, yung mga crystals natin or mga regular crystals natin, it takes a lot of time to form. Para makapag-form sila ng stable at distinct na pattern ng structure ng atoms. Ayan. Okay, so a morphosolid lack of regular three-dimensional arrangement of atoms. So, ang example ng amorphous solid is glass. So glass commonly refers to an optically transparent fusion product of inorganic materials that has cooled to a rigid state without crystallizing. So ito yon, nag-cool siya rapidly. So ibig sabihin hindi nakapag-produce ng distinct pattern ng uniform na structure ng atoms. Ayan. So by product of fusion, we mean that the glass is formed by mixing molten silicon dioxide with compounds such as sodium oxide, boron oxide, and certain transition metal oxide for color and other properties. Ayan. So silicon dioxide is a chief component of glass. So ito yung main component ng all types of glasses. So in some aspects, glass act more like a liquid than a solid. So since si glass ay amorphous solid, so naglalak siya ng long range na periodic order, na merong uniform na crystal structure. Ayun. Tapos, nagpo-produce din siya ng poor na defined patterns during X-ray diffraction. So yung X-ray waves na i-interpret or napoproduce ay not distinct or defined. Okay. Ito naman, napakita ko na din 'to as example sa inyo nung last week, sa pagdi-differ sa crystalline, solid, and amorphous. So ito naman medyo specific lang. So si figure A is crystalline quartz, and then si figure B naman ay non-crystalline quartz, or quartz glass, non-crystalline quartz glass. So itong A ay crystal, nag-form into crystal, while si B ay nag-form lang siya into glass lang. Ayan. Ito ay yung sa glass lang. So, as you can see naman, sa pattern pa lang, very obvious naman yung difference nila. Ayan. Okay, so meron tayong three types of glasses. So, first is the pure quartz glass. Second is the Pyrex glass, and third is the soda lime glass. So, magdi-differ yung tatlong types ng glass na yan sa composition, sa properties, at saka sa uses. So, sa composition, nagdi-differ sila sa kung gaano kadaming silicon dioxide yung sila composed. Yan. So, si pure quartz glass, siya ay 100% na silicon dioxide. Tapos si Pyrex glass naman ay 60 to 80% lang yung composed ng silicon dioxide sa kanya. Tapos 10 to 25% at small amount yung other compounds. So si soda lime naman ay 75% lang yung sodium dioxide niya. Tapos 15% and 10% naman yung other compounds. Ayan. Tapos in terms of properties and uses naman, so si pure quartz glass and si Pyrex glass is parehong low thermal expansion. And then, si pure quartz glass is transparent to wide range of wavelengths. So it is used in optical research. Okay. So ginagamit ito in optical research. While si Pyrex glass naman, transparent to visible and infrared, but not to UV radiation. Okay? So it is mainly used in laboratory and household cooking glassware. So yung ating mga diniscuss na laboratory glassware, so yun ay usually made up of Pyrex glass. So yung ating mga test tube, yung ating mga Erlenmeyer flask, yung ating mga graduated cylinder, and other laboratory glasses or glasswares, so yun ay made up of Pyrex glass. Okay? Tapos same with our household cooking glassware din. Ano, yung ating mga ginagamit sa bahay, pangluto ng glasswares. Ah, yun, made up of Pyrex glass din siya. So si soda lime glass naman, it is easily attacked by chemicals and sensitive to thermal shocks. So it transmits visible light but absorbs UV radiation. Okay? So um, kung si Pyrex glass ay nagtatransmit, ano, ay transparent to visible and infrared, at pero hindi siya nagtatransmit ng UV radiation, si soda lime glass naman ay nagtatransmit ng visible light but it absorbs UV radiation. So, mainly siya ay ginagamit sa windows and bottles. Ano, so, yung ating windows, kaya siya ay, yung mga glass sa ating windows, ano, nagtatransmit ng visible light ano, sa labas. Ayan, para to serve its purpose. Ayan. Also sa bottles, soda lime glass din. Okay, so there are about 800 different types of glass in common use today. So the color of the glass is because of the presence of metal ion as oxides. Ano, so for example, meron tayong tinatawag na green glass, yellow glass, blue glass, and red glass. So marami pa yan. Ano, yan ay yung mga colors ng ating glasses ay nakadepende sa presence ng metal ions ano, or presence of other chemical element or chemical compound na present ano, dun sa mismong glass natin. So, ito yung for examples ng. So, green glass, it contains iron oxide, iron 3 oxide, or copper 2 oxide. So, si yellow glass naman, it contains uranium oxide. While si blue glass, it contains cobalt 2 and copper 2 oxides. And then si red glass, it contains small particles of gold and copper. Okay? And then most of the ions mentioned are derived from the transition metals. Ayan. So yung transition metals na yan ay yung hindi, ayan, itong B2O3, Al2O3, Na2O, tsaka CaO. Tapos yung mga, ano pa, other, anong tawag mo doon? Doon sa, I forgot the term. Nakalimutan ko yung term. Yung hindi kasama talaga. Parang dumi. Ano bang term dun? Kalimutan ko yung term. Basta yung, 'di ba may composition tayo? Ano, ayan. So ito, yung ating main composition, ano, ng glass. So silicon dioxide, and then meron tayong mga transition metals. Ano, tapos yung parang mga excess na, ano siya, parang waste. Um, hindi siya talaga ah, dapat nandun sa composition na iyon. Nakalimutan ko yung term. Anyways, ayun. Yun lang yung about amorphous solids. So, meron ba kayong questions? Any questions, clarifications, or anything? Ayun, meron ba kayong question dun sa final project or anything? Okay. Silence means none. Sorry, hindi ko agad nabasa yung question ni Mr. Leideros. But to confirm, yun ba yung tinutukoy mo yung sa competition natin kanina sa, um, yung yung last na problem solving?
Yes po, ma'am.
Okay, okay na? Same nung, okay. Sige, thanks. Ayan, hindi ko kaagad nakita yung chat mo sa ano, sa chat box. Ayun, so yun lang yung about Crystal. So, kung wala kayong questions or clarifications, meron tungkol sa project, um, puwede naman na i-ano niyo ako, i-message ayun. So, 'pag Messenger hopefully lalo na 'pag hindi natin time, ano, um, pa-expect na lang ako ng, delayed na response Pero I will reply naman sa inyo. I will get to it naman, ah, hangga't may time ako at kaya ko, ayan. And then, yun kung wala kayong questions or any clarifications or anything, yeah, you may leave the room. So that's all for today. Bukas na lang ulit sa next topic natin which is metals. So itong ating slide na updated para dun sa sinolve natin na problem kanina, i-upload ko na lang siya sa Google Classroom ulit So if not, i-try ko siya upload today kung kakayanin kasi medyo nagloloko kasi yung di ko alam kung Wi-Fi ba ng university or yung Google Drive ko kung puno na ba. Since 10 GB lang kasi yung ina-allow sa amin dito sa account ko. So, ayun, kung hindi ko siya ma-upload today, i-upload ko siya tomorrow. Itong updated slide ng ating Crystal para meron kayong makuha na solusyon dun sa ating mga problem solving kanina. So, ayun lang, you may leave. See you tomorrow na lang ulit. Thank you.
Thank you po.
Ay, yes, Mr. Pamplona.
Ma'am, online po tayo bukas.
Oo naman. Tayo, 'di ba ngayon, Adweek.
Apo. Thank you po.
Okay.
Thank you po, ma'am. Thank you po.
Thanks, Mom.
Ma'am,
Thank you po, ma'am.
may question lang po ulit si Lideros.
Go ahead.
Nasa chat po.
Ano yun?
Hello po. Dun po sa pagpili po ng topic po sa case study po dun sa mga title po. Kami po ang pipili po or dun po kami magbe-base sa mga binigay niyo po sa G-class.
Paanong binigay sa Gcash? Same lang yun. Parang pare-pareho yun Meron ba kayong nakitang difference? I mean, yung, di ba, ilan ba yung file na sinend ko? Pero meron akong file na sinend doon na dun lang solely yung 37 na cases. Na dun kayo pipili nung 20 na aaralin ninyo. Pero yung na yun, yung 37 na yun, lang yun, pare-pareho for all 3 sections na handle ko. Yun. So, naman, kahit naman, siguro naman walang magkakapareho ng parehong-pareho na 20, yung same na 20 sets na yun per group sa other sections. Or kung man magkapareho, parang very impossible naman kung parehong-pareho pa rin kayo ng magiging introduction, analysis, tsaka yung recommendations and conclusions. So, kapag parehong-pareho yung cases, parehong-pareho din yung naging analysis. So, na yun, copying na, regarded as copying na. Pero, I think wala namang issue kasi naman yun, 37 tapos 20 naman. So, kung magkakapareho man kayo nung combination ng 20 na yun, magkakaiba pa rin naman kayo dun sa magiging analysis ninyo. Pero malinaw ba dun kayo pipili, dun sa file na sinend ko na 37 cases, dun kayo pipili ng 20. Tapos take note na lang dun sa dun sa nilagay ko dun sa format, and guidelines, yung instructional materials, na yung sunod-sunod. So, dapat after ng front page, ang sunod na nun is yung case na unang napili nyo, and then sa next page would be yung analysis for that first case. Tapos sunod-sunod, ganun. Ganun yung format. So hindi sana walang mag-submit sa akin sa finals ng ng sama-sama yung 20 or kung ilan mang cases sa unahan tapos sama-sama din yung analysis sa likod. Wag ganun. Yung lang, sundin niyo yung pattern na binigay ko. Okay na?
Thank you po.
Okay. May other question pa ba?
Thank you po.
Okay, kung wala na, yeah, you may leave na. Thank you.
Thank you po, ma'am.
Thank you po, ma'am.
Ma'am.
Thank you po, ma'am.